example 3 is the same as examples 1 and 2. If you are trying to graph the square root of any function, first of all, you have to have the function graph. And the nice thing about equations 1, 2, and 3 is they graph them all for us. We are going to do another one right after this for ourselves that we have to graph. But if the graph is already drawn, which it has in f of x, then we're going to use those ideas that we saw in that activity at the beginning, that the only square roots that stay the same are 0 and 1. So if you go on your graph and you go across and you label, are there any points that are 0? And are there any points that are 1? You can label those right away. Next. Are there any nice points? Unfortunately on this, oh, man, sneaky. Did you see how sneaky this was? The scale is going by half. So 1 is actually higher up. Oh, I don't like when they do that. You get so used to just counting the boxes, right? So you be careful that you're reading the scale carefully. But there's no nice, like, the nicest square root that I could do after this would be 4. That's off of my graph. Next, what did we learn? We learned that if you square root a big number, you always get something small. Like square root of 4 is 2, square root of 9 is 3. So any time that your y values are bigger than 1, your square root graph has to be below the red graph. But anytime you're between 0 and 1, then your blue graph will be slightly above. And as long as you're slightly above, does not go past 1 or go back in time, you're fine. So that would not be okay. We just need to be slightly above. So this is all that's asked for. As far as this question, it asked for the domain and range. The domain here, x is bigger than or equal to 1 on the blue graph, because you can't square root the negative. And the range, y is bigger than or equal to 0. All of the questions in the textbook so far have given you the graph. So we're going to do another example here. You can write it in the space. You probably have enough space underneath to do this. We're going to graph. The question would just say graph the square root, and then inside could be anything. So let's just say you were asked to graph the square root of, since we have our logs test coming up, log base 3 of x plus 1. So what you would have to do first is graph the inside. So graphing the inside in green, what does this look like? This is a log graph that's been moved 1 to the left. So what does that mean for me? Well, log graphs have an asymptote at x equals 0. This one would have an asymptote at x equals negative 1. My original log base 3 graph, right? You would have the point 1, 0 and 3, 1. That's your basic log graph. Everything has to be moved 1 to the left. So I hope that you can see that you have 0, 0, and 2, 1. And this green graph would be log base 3 of x plus 1. It's just your log 3 graph, moved 1 to the left. Now, if we wanted to graph the square root of that, again, once the graph is made, your steps are exactly the same every single time. You're going to look Is the graph ever 0? Is the graph ever 1? Yes. That's where my y values are 0, are at 1 and at 0. Between 0 and 1, your graph has to be slightly above, and afterwards, slightly below. So this is the graph of the square root of a log graph. Its domain would start at 0 because you can't take the square root of a negative number. And it also helps review for us, how do you graph logs? Because you're going to be asked to graph logs and natural logs on your test on Friday. Okay, questions for practice on this one are 10 and 12. And the last question in this section is, okay, we're actually going to change it and do it with algebra instead. Yes.